Okay, today we're going to look at lines cut by transversal. The definition of two lines cut by, or more lines can be cut by a third line, or here in this picture I have M and N and they're being cut by T, the transversal, to show that they form different kinds of angles. And here's a list of the names of all the angles. You'll notice a lot of them have to do with interior and exterior, and that's talking about the two lines that they're related to, M and N. Are you on the outside of those lines, or are you on the inside of those lines? The last one, corresponding, it's a little different, so we'll talk about that as we go through, because it's not an interior or exterior pair like the others. Now let's go into more depth on each one of these as it's cut by a transversal. So now first one, we want to talk about exterior angles. So you want to get colored pencils to do this. So if you need to stop the video and go get some colored pencils, do so. So here is an exterior angle. And an exterior angle in this problem is an angle that's outside of your two main lines. So I don't want to be between the M and N line. I want to be outside of it. And so there's another one right beside it. And there are two down here at the bottom. Maybe that would be better if we made those all different colors. Let's try that. So here are two of them on the outside, and here are two more that are on the outside, so that you can see there are four angles on the outside. Now if I talk about interior, that means I want to be between these two lines. And so between the two lines, if these are my two lines I'm talking about, there would be an interior angle here and here. But there would also be an interior angle on the other side of the line as well. So there are four angles outside and there are four angles inside. Now, if you're not talking about inside or outside, then you're talking about corresponding angles, and corresponding angles are in the same position around the intersection. For example, if I talk about the top left position here at this intersection, then I would compare it to the top left at the bottom intersection. If I'm talking about the top right on this position, then I would be talking about the top right at the other position. If I want to talk about this bottom left position at the top one, then I'd be talking about the bottom left down here. And last but not least, if I want to talk about the bottom right position, then I would be talking about this one down here. So those, one's outside and one's inside in each individual place. So you have to look at it in terms of it's located in the same position around the intersection, because there's not both are outside or both are inside. It's one of each. Then alternate exterior angles are angles that are on the outside. So for example, this is an outside angle. To be alternating means on different sides of the line, so I would have to compare it to this angle down here, because they are both outside the two lines and they are on different sides of the transversal. This means on different sides of T, and this means outside. There's also another pair of these alternate exterior angles. There will be one here on the top left right position that goes with this bottom left position, because they are outside but they're alternating. Alternate interior angles do the same thing. If you have one on the interior, it's got to be on the opposite side of the line on the interior, versus this angle here would go alternating with this one, and they're both interior. Now for consecutive interior and exterior angles, there's another name for that. It can be called the same side exterior. That's what the consecutive word means. So if I'm on the exterior, and I choose this angle, then I want to choose one on the left side down here on the exterior, because it is got to be outside the two lines but on the same side of the transversal. There's another pair of these as well on your graph, here on the right side and here on the right side outside those two angles. Now you also have another pair of these consecutive interior angles. Does the same thing. If I'm on the left side of the transversal, I want to stay on the left side and be between the two lines. Or if I'm on the right side of these two, I want to be on the right side in between the two lines to be consecutive interior, because it means on the same side of T and between your lines. Interior means between. So these angles are not, they're not the same size, they're just locations of where these angles are. So now we're looking at identifying the names of each angle by location on the lines cut by this transversal. So our transversal this time is R, and we're looking at, we have lots of angles labeled on M and M, so we want to see how they relate to R. So first we're looking at angle 2 and 3. So here is angle 2, and here is angle 3, and here's my transversal. And what you'll notice is they're on the same side of the transversal, but they're between the two lines. So that makes them consecutive interior angles. So that's what you're doing on this page, is you're trying to locate the two lines and name them. Let's do one more together. So let's mark angle 8 and angle 6. First of all, one's at an exterior angle and one's an interior angle, so that's a pretty good clue right away that these are corresponding, because they're both in the bottom left position. So corresponding angles. So stop the video and see if you can determine the names of all the other angles. And when you have finished doing that, turn the video back on and check your work. So next we have angle 4 and 6. Angle 4 and 6 are vertical angles. We studied that in our last unit. So we'll continue to pull in some of the angles that we knew before. How I know they're vertical is they touch. See, corresponding angles, they're all, one's inside and one's outside. Vertical angles, one's inside and one's outside, but they're at the same intersection where corresponding angles are not. All right, now let's look at angle 1 and 2. Angle 1 and 2 are side by side. That makes them supplementary because they add up to 180. That's another angle that you studied in the previous lesson. Now let's look at angle 3 with angle 7. First of all, they are alternating because they're on different sides of the transversal, but they're between the lines, so they're interior. So they're the alternate interior angles. Next we have 1 and 5. They are both outside those two lines, but they are alternating on different sides of the transversal, so they are alternate exterior angles. And then last but not least, we have 5 and 8. You'll notice they're both exterior. They are both on the same side of the line, which makes them consecutive. And it's getting too long. Let me abbreviate that. Consecutive, they're exterior because they're outside the two lines, but on one side of the transversal. Consecutive means on one side of the transversal, and exterior means outside the two lines. All right, so here in this lesson, you've got to look at, they're color-coded, but on your copy they're not. So you need to mark them with your colored pencils, mark the blue angles and mark your red angles with those colors, and then try to name them based on which one of these they might be. Now you can stop the video and answer these questions and then come back and check yourself in a minute. So angle 1 and 2 are on one side of the transversal, but they're both in the bottom right corner, so that makes them corresponding. And then the blue angles, angle 3 and angle 4, are both on the interior of the lines, and they're on different sides, which makes them alternate. So they are alternate interior. Well, angles. All right, let's look at the picture beside it. Let's start with the blue angle since I've already got the blue marker. 5 is in the bottom left corner, 6 is in the bottom left corner. That makes them corresponding because they're in the same position at both intersections. Then with angle 1 and angle 2, they're both on the right side of the transversal between the lines, so that makes them consecutive interior angles, because if you're on one side of the line, you're consecutive, and if you're between the lines, you're interior. Now in this problem, we have lots more lines, but focus on the 2 lines that actually touch the angles you're talking about, because the transversal is going up and down. So here with angle 1 and angle 2, we notice that they're both in the top right corner, so that makes them corresponding. But with the blue ones, let's focus on the top line versus the bottom line, and just ignore the middle line because those 2 angles don't touch the middle line. And in that case, they're between the top and the bottom line, and they're on different sides of the transversal, so that makes them alternate interior angles. Alright, so let's look at our next slide and see where we're going with these names of angles. Well, if the lines happen to be parallel, they have a better relationship. See, the lines we've just been looking at are not parallel. So I think what we will do now is we're going to stop the video, and let me show you the assignment. You can go out into Canvas and find homework 2.1. The first whole page relates to what we were just going over in the slides. So my suggestion would be to, yes, the first whole page, all 1 through 9, all relate to just naming it because of where it's located. So hopefully you can go through and do these parts and come back and finish watching the video. Because the second page of this relates to the size of the angles, and this first page just relates to the location. So again, we're looking at parallel lines cut by transversal now that you're back from doing the first page of the worksheet. So at the top here we have corresponding alternate interior and alternate exterior angles are congruent, and when you make the lines parallel, they look the same size, where if I go back and look at these over here, these corresponding angles at 1 and 2 definitely don't look the same size, although they're close, but they're not exactly. And then down here at the bottom, 2 parallel lines cut by a transversal so that pairs of angles are supplementary. Your consecutive ones, your ones that are on one side of the line on the interior or on the exterior, add up to 180 because it looks like you'll have an acute and obtuse angle. They won't be acute or both be obtuse. So let's look at this more in depth. So here we have corresponding angles. And so what they want us to do with this is locate these angles on a picture and label them so that we can say where they're located is definitely corresponding. So with angle 2 and 6, we're going to put 2 here and 6 here because they're in the top and the right side of the line. Now we're going to switch colors to green, and we're going to put in 1 and 5. 1 and 5 go here, and they're in the top and the left position. Next, we're going to put in 3 and 7, and 3 is going to go here, and 7 is going to go here, and this makes it the bottom right position on each one, because corresponding have to be in the same place. And as you can see, 3 is in the bottom right of that intersection, and 7 is in the bottom right of this one. And then for the last one, we're going to put angle 4 and angle 8 in because they're both in the bottom left position. So we're going to go through and do this with each set of angles. And we may not put the numbers in the same place every time, but the colors are going to coordinate to these names of these angles over here so that we can see that bottom left or bottom right positions. Okay, so next we have consecutive. There are only 2 pairs of consecutive angles. The first one is 3 and 5, add up to 180. Let's put 3 and 5 on this side. These 2 angles, this is an acute, this is obtuse, but together they're going to make 180. And then on the other side, we're going to put 4 and 6. And as you can see, they're right the opposite. This is the acute, and this is obtuse, but they do add up to 180 because they are on the one side but interior up to the angles. So in our next one, we have the opposite effect. We have them on the outside and consecutive. So we have 1 here and 7 here. And we would have 2 over here and 8 over here, so that they look like an acute and obtuse add up to 180. Now we have alternating angles. Alternating angles are on different sides of the transversal. They are always congruent, which is what this little symbol here between them means. So if I put in 4 and 5, 4 and 5 alternate. But if I put in 3 and 6, they would alternate the other way. See how they're between the lines, but they're on different sides of the transversal. That's what alternating means. Opposite sides of the transversal, not touching each other, but they look the same size. 3 and 6 both look obtuse. 4 and 5 both look acute. So in alternate exterior angles, do the same thing. First, let's do the green one. I have 1 and 8, both look obtuse here. They're both outside. They're alternating on different sides of the line. And then we have 2 and 7 are on the outside, and 2 and 7 are alternating, but they're both acute. So that's how alternating angles work, is they're equal to each other, so they have to be on different sides of the transversal for that to happen. So now we're going to look at what if I am asked to find some angles that are supplementary to it. How do you know? Well, first of all, let's label it. This one's 55 degrees. Now we know that 2 on a straight line are supplementary. So angle 3 and angle 4 add up to 180 because they're side by side. One's acute, one's obtuse. So we know that's what it would be. But angle 3 is also supplementary to angle 2 because they add up to 180 degrees. So if you have 2 angles side by side, we know they add up to 180. But we just learned a new rule that says if they're on the same side of the transversal, they add up to 180. So angle 3 is also to angle 8 being supplementary because they are consecutive interior angles, where these two are just plain old everyday supplementary. So you can find out lots of supplementary angles to another measure and find them actually, because you can take it away from 180. So 180 minus 55, borrow, that's going to be 125. So this one's 125, this one's 125, and this one's 125, and they look 125 because they all look obtuse. Says, what are the measures of angle 3 and 4? Which theorem or postulate justifies your answer? So first you have to figure out how big are 3 and 4. Now they're not even on the same transversal, so that might have something to do with it. Well, first of all, I would say angle 3 is going to be compared to angle 105 because they're equal to each other. The measure of angle 3 is 105 because these are alternate interior angles. All right, so now that I know those two are alternate interior angles, I can now go back and talk about angle 4 with angle 105 because angle 4 plus 105 makes 180. So we found angle 3 because it looked the same size as angle 105 on parallel lines. And that's what these little symbols right here mean, that these lines are parallel. And so then we could look at 4 and 105 are consecutive interior. If you look at Q being the transversal cutting across L and M, and therefore angle 4's measure is going to be equal to 180 minus 105, which is 75 degrees. So if they look the same size on parallel lines, they are the same size. But you have to justify it by which kind of angle do you have. So last but not least, I think this is our last slide. Let me see. No, it's not. I tell you what, let me skip over that one and come back to it in a minute. Which lines or segments are parallel? So we look at these positions and decide. So this is top right. So that makes them corresponding. Since they are on the transversal of EG, then the BE line is parallel to CG by the transversal EG, because they're both on EG, so that has to be the transversal that cut across here. That's what you're doing here. So let's look at the next one. Here's two lines cut by a transversal. Again, they're corresponding. So we name the two lines. PQ is your transversal. And PS and QT are parallel. Let me use a parallel symbol. By the transversal PQ. All right. You have to draw the two lines that cross each other. It's transversal. So in this case, I have again corresponding, but this time it's HR is parallel to CA and is cut by the transversal RM. Alright, and our last example here on this page, if you look at that, it's still corresponding. Every one of these was corresponding. It's just different kinds of lines. So KR is parallel to MT and is cut by the transversal JM. So now let's go back to that last slide. To wrap up this lesson, what she's going to ask you to do in this lesson is measure of angle 1 is 100. That's what you've been given. You're supposed to go through and make the relationship of, if that's 100, how does it compare to each angle? And you should be able to compare angle 1 to everything on that transversal except for one angle. So I'm going to go through and get you started on angle 1, and then you can do all the angles from 9 to 15 on your own. So the measure of angle 1 being 100, if angle 1 and angle 2 are supplementary, because they're side by side, add up to 180, then the measure of angle 2 is equal to 80. Now, the measure of angle 1 and the measure of angle 4 are also supplementary because they're side by side. So the measure of angle 4 is 80. And the measure of angle 1 and the measure of angle 3, they are vertical, they're congruent, actually they're just, let me just use an equal mark, that'd be easier. So that means the measure of angle 3 is equal to 100. We're halfway through this set. You keep using angle 1 as long as you can. So the measure of angle 1 is equal to the measure of angle 5 because they are corresponding. See how it's in the top right, left position, top left position. So the measure of angle 5 is equal to 100. Then measure of angle 1 is, and the measure of angle 8 add up to 180 because they are consecutive exterior. So the measure of angle 8 is equal to 80. So now we know this one's 80 and this one's 100. And then the measure of angle 1 is equal to the measure of angle 7 because they're corresponding. Excuse me, not corresponding. This angle and angle 1 are alternate in exterior. So therefore the measure of angle 7 is equal to 100 because they're equal. And the only one I couldn't label was 6 because 6, it doesn't have a relationship to 1, but you can make a relationship with it to any other angle. So the measure of angle 8 is equal to the measure of angle 6. So the measure of angle 6 is equal to 80 because these are vertical angles. Is the easiest one to do. So now, what I'd like you to do is see if you can go through and do the same thing with 9 through 15. And to get you started, the measure of angle 1 is equal to the measure of angle 9 because they're corresponding, which means that the measure of angle 9 is 100. And now you have angle 9, and you can go off and make everything equal to angle 9 for your next part. So do that, and that'll be the end of your notes.